adversarial machine learning. Attackers will go after your machine learning solutions. Machine learning algorithms, as commonly implemented, are extremely vulnerable to changes to the input data, features, and the final model parameters or hyperparameters that are generated. Essentially, an attacker can exploit any of these vulnerabilities and subvert machine learning algorithms. As a result, adversary can learn an approximate model using fewest possible queries, or called model extraction. In model poisoning, attackers can go undetected either by increasing the false negative rate, attacks are misclassified as normal activity, or by increasing the false positive rate, attacks get drowned in the sea of noises, which causes the system to shift the baseline activity. Adversarial examples are input to machine learning models that an attacker has intentionally designed to cause the model to make a mistake. They are like optical illusions for machines. Adversarial examples represent a concrete problem in AI safety that can be addressed in the short term, and fixing them is difficult enough that it also requires a serious research effort. To get an idea what adversarial examples look like, consider these demonstrations from the paper explaining and harnessing adversarial examples. Starting with an image of a panda, the attacker adds a small perturbation that has been calculated to make the image to be recognized as a gibbon with high confidence. An adversarial input overlaid on the typical image can cause a classifier to miscategorize a panda as a gibbon. Adversarial examples have the potential to be dangerous. For example, attackers could target autonomous vehicles by using stickers or paint to create an adversarial stop sign that the vehicle would interpret as a yield or another sign, as discussed in practical black box attacks against deep learning systems using adversarial example papers. There are more adversarial examples with the link provided in our resource section. To address adversarial machine learning, the first and most important step to address this is to start the practice of threat modeling of your machine learning solutions. Here is a commonly used framework. Define the adversary's goal. For example, is the attacker attempting to evade detection? Can the attacker poison the data? Assemble the adversary's knowledge. Does the attacker have limited knowledge of the data science solution or perfect knowledge of any of the following? The training data set or part of the training data set, the feature representation of each sample, such as how real objects, such as emails and network packets, are mapped into classifier's feature space, the type of learning algorithms, and the form of its decision function. The trained classifiers, such as the weights of a linear classifier. Determine the adversary's capability. Can the attacker poison the dataset, tamper with the machine learning model, or subvert the alerting system? The second step is to chart the necessary steps to protecting your data pipeline end-to-end. This includes securing the data uploader as well as the repository that ultimately hosts the input data and the machine learning models. Finally, check out Adversarial Lib, an open source tool for testing your machine learning algorithms against common attacks.